Welcome you all. Now we are going to discuss the topic high voltage testing of electrical apparatus. It is very essential to ensure that the electrical equipment is capable of withstanding the voltages that are met with in service. The over voltages may be either due to the natural causes like lightning or system originated such as switching or power frequency transient voltages. So hence the testing of electrical apparatus plays an important role. Then testing of insulators and bushings. See here we are going to discuss the different over voltages of testing done on insulators and bushings. We are going to discuss the over voltage tests are classified into two groups, that is power frequency voltage test. Another one is impulse voltage test. So these tests together will ensure that the over voltage withstanding capacity of an apparatus. So before going to the topic, we are going to discuss some of the terminologies of the technical terms which we are going to use. So that is nothing but the definitions. In test codes and standard specification, certain technical terms which we are going to use and to specify the defined conditions or the procedures. Hence, commonly used technical terms are going to define here before the actual testing of the electrical equipments. So that is nothing but the first one, disruptive discharge voltage. So this is defined as the voltage which produces the loss of dielectric strength of an insulation. So this is nothing but it is the voltage at which the electrical stress in the insulation is going to cause us a failure, which includes the collapse of voltage and to pass of the current. So usually in solids, so this is going to happen as a permanent loss of the strength, and in liquids or the gases only temporary losses may be caused. So when there is a discharge takes place between two electrodes, so in the gas or the liquid or the solid, it is called flashover. If the discharge occurs through a solid insulation, it is called as puncture. So next definition is the withstand voltage. This is nothing but the voltage which has to be applied to a test object under specified condition in a withstand test. Then it is called as withstand voltage. So for these details, you can refer that IS 731 and IS 2000 part 1963. Then next we have 50% flashover voltage. So this is nothing but the voltage which has the probability of 50% flashover when the applied to a test object. So this is normally which is applied, which is used in the case of the impulse test, which the loss of the insulation strength is temporary. Then next we have 100% flashover voltage. This is nothing but the voltage which causes a flashover at each of its application under specified condition. When the voltage of the test object which is specified is 100% flashover voltage. The next one we have a creepage distance. So this is nothing but the shortest distance on the contour of the external surface of the insulation unit or between two metal fittings on the insulators. So generally, one of the electrode which is kept fixed and another electrode which is going to move is depending upon the flashover voltage, which we can able to vary the creepage distance between the two electrodes. Then next we have AC test voltages. The alternating test voltage with of power frequency should have a frequency range of generally 40 to 60 Hertz and should be approximately sinusoidal. So generally the deviation which is allowed from the standard sine wave is of about 7%. The deviation is checked by measuring instantaneous value over a specified intervals and converting the RMS value, or that is nothing but a computing the RMS value, the averaged value and the form factor. Then we have impulse voltages. So impulse voltages are generally characterized by polarity, peak value, time to front and time to half the peak value after the peak, or that is nothing but generally we'll call it as rise time and the fall time. According to definition, the front time is defined as 1.67 times to between 30 to 90% of the peak value in the rising portion of the wave. According to IS 2071, the standard impulse wave, which is defined as rise time of 1.2 microsecond and the fall time, that's the total time of 50 microsecond. Generally it is called as 1.2 bar 50 microsecond waves. So generally the tolerance which is allowed is plus or minus 3% in the peak value, plus or minus 30% in the front time and plus or minus 20% in the tail time, because it is very difficult to find out what is the peak value. So that's why where there is a tolerance which is allowed for peak values of plus or minus 30%. Then other than that, we have some reference atmospheric condition. Some of the electrical characteristics of the insulation and other apparatus are normally referred to the reference atmospheric conditions. According to that Indian standard specification, the temperature is of 27 degrees Celsius and the pressure of 1013 millibars, generally we will call it as 760 torr, and the absolute humidity is of 17 gram per meter cube. Because it is not always possible to test these references conditions of the correction factor has to be applied. In some cases, some of the test conditions are also used, that is nothing but British standard specifications. According to that, there the temperature is of 20 degrees Celsius and the pressure is 760 torr and the absolute humidity of 11 gram per meter cube. And we have air density correction factor of, generally D is nothing but, we are going to use, that is equal to 0.289 B divided by 273 plus T for 20 degrees Celsius. So B or P, which we can use it for atmospheric pressures in the millibars, and the T is nothing but the atmospheric temperature in degree Celsius. Test on insulators. The tests are normally conducted are divided into two types. First one is type test and another one is a routine test. So in a type test is used to check the design features and the quality. Whereas in case of routine test, it is used to check the quality of the induced test pieces. In a type test, which are done on samples when there is a new design or design changes are introduced. Whereas the routine tests are done to ensure the reliability of the individual test objects and quality and consistency of the materials which is used in manufacture. So in high voltage test, which includes power frequency test, impulse test, all the insulators are tested for both categories of the test. First one, that is nothing but a power frequency test. In that, we are going to discuss, that is dry and wet flashover test. In this test, the AC voltage of a power frequency is applied across the insulator and increased at a uniform rate of 2% second 2% per second of 75% of the estimated test voltage. So this is nothing but why we have to vary a 2% per second till the maximum value of 75%. So if you suddenly increase the value, so we know that the breakdown strength of the insulators is very high. So if you are operating slowly, so then actually we are going to test the breakdown strength. Otherwise, suddenly if there is a rise in the voltage across the insulator, this exhibits the maximum breakdown strength than the actual value. To such that the breakdown occurs along the surface of the insulators. If the test is conducted under normal condition without any rain, then we'll call it as a dry flashover test. If the test is conducted under normal conditions of the rain, then we will call it as wet flashover test. In generally, the wet tests are not intended to reproduce the actual operating condition, but only to provide a certain based on experiences that are satisfactory under a service operation will be obtained. Generally, the test object which is subject to a spray of the water of given conductivity by means of the nozzles. The spray is arranged in such a way that the water drops falls approximately at an inclination of 45 degree to the vertical. The test, the object is sprayed at least for a 1 minute before the voltage application. And also the spray is continued during the voltage application. The certain characteristics of the spray which is noted as a precipitation rate of a 3 to 10% plus or minus, and the direction which we know that is 45 degree, and there is an conductivity of the water will be of 100 microsiemens plus or minus 10%, and there is an ambient temperature of 15 degree Celsius plus or minus. So relating to this, so you can refer, there is a document of according to the IEC which has been revised, and the test procedure and the precipitation conditions are newly updated. According to that, the vertical component average precipitation based on that vertical component is of 1 to 1.5 mm per meter per mm per minute, and horizontal component same thing, and the limit for individual measurement of 0.5 to 2 millimeter per minute, and the temperature which is collected of the water is of plus or minus 15 degrees Celsius, and the conductivity is 20 degrees Celsius is of 100 to 100 plus or minus 15 microsiemens. So these are the things which is specified. These are the things which is modification for the application of 15 positive and 15 negative impulses. So in that, 2 in each set are allowed for the flashover. If it is more than the 2 flashovers in each set, then the insulator is said to be have failed the test object. So this is the procedure is satisfactory for equivalent to the which is mentioned for dry and wet flashover test. Then coming to that next one, that is dry and wet withstand test for 1 minute. So here in this test, the test piece should withstand the specified voltage which is applied under dry or wet conditions for the period of 1 minute within the insulator which is mounted as in the service condition. So this has to be withstand at the specified voltages. So next one is impulse test. So in that there are the 3 different type of the test, that is impulse withstand voltage test, impulse flashover test, and there is an pollution testing. So coming to that first one, that is impulse withstand voltage test. So this test is done by applying, there is a standard impulse voltage of the specified value under dry condition with both the positive and the negative polarities of the waveform. So if the 5 consecutives of the waves do not cause us there is a flashover or the puncture, then the insulator is said to be the test is passed. If the 2 applications causes there is a flashover, then the object is said to be it is failed. So if there is only one failure, then we have to do a additional 10 applications of the voltage waveforms are made. If the test object which has withstood the subsequent applications of the standard impulse waveforms, then it is said to be the insulator is passed the test. So this plays an important role. So we will see to that. So you should not make any flashover within a 5 consecutive application of the voltage waveforms. The next one is impulse flashover test. The test which is done as the same thing what we explained in the previous concept with a specified voltage. Generally, the probability of the failure which is determined in between a 40 to 60% of the failure which is going to be taken, then the insulator surface should not be get damaged. The failure values generally is of 20 to 80% the failure values. It is very difficult to adjust with the test voltage for the exact 50% of the flashover. So that's why we are going with a 40 to 60 and 20 to 80% of the failure values. So generally the average values of the upper and the lower limits which is going to be taken, the insulator surface should not be get damaged by these tests, but there is slight marking on the surface which is allowed on the surface of the insulators. The next we have a pollution testing. Because of the problem with related to the pollution of the outdoor electrical insulation and the problems of the maintenance of the electrical power system, the pollution testing which is going to be a very important concept. The normal types of the insulation which is going to be considered, that is the first one is dust, microorganisms, bird secretions, flies, etc. Then we have another type, that is industrial pollutions like smoke, petroleum vapors, dust and other deposits. And next category we have coastal pollutions, in which corrosive and hygroscopic salt layers which are going to be deposited on the surface of the insulators. Next category, that is desert pollution, which is going to be because of there is an sand storms will causes there is an deposition of the sand and the dust layers on the surface of the insulators. And next we have ice and fog deposits at high altitudes and in polar countries. The pollution will cause us there is a corrosion and resulting in there is a deterioration of the material, and also there is a problem which is associated with the partial discharges and radio interferences. At a present day, there is no such a pollution test which is available. There is a popular test that is normally done, that is nothing but we'll call it as salt fog test. So here in this test, the maximum normal withstand voltage which is applied on the surface of the insulator, and there is some artificial salt fog which is going to be created around the insulators by jet of salt water and with the help of some compressed air. So if there is an flash show occurs within 1 hour, then the process is repeated with fog or lower salinity. Otherwise, with the help of with a fog to higher salinity. So generally, the maximum salinity which the insulator withstand 3 out of 4 tests without there is a flashover. It is been taken as a representative figure. So in this regard, a lot of the work has to be done to make it the standardization in the test procedures and to concerning of these different type of the pollution which is going to be in deposition on the surface of the insulators. Then that's why it is a quite challenging task to ensure the breakdown strength of the insulators. Next concept is testing of bushings. Actually, there are the 3 different types of test we are going to conducting on a bushing. That is power frequency test, then impulse voltage test, next thermal test. So we can discuss one by one. In power frequency test, again there are the 5 different type of test. That is power factor voltage test, next internal or partial discharge test, momentary withstand test at the power frequency, then 1 minute wet withstand test at a power frequency, visible discharge test at a power frequency. Means we are conducting on based on a power frequency test at a 50 to 60 hertz of the system. In the first one, power factor voltage test. So in this test, bushing is set up as in service or in immersed oil. So it is connected in such a way that line conductor goes to high voltage side and the tank or earth portion will goes to detector side. Means one of the side is connected to high voltage side, another side is connected to the tank or earth portion which is connected to the detector side, or there is a sharing bridge. So there is an voltage which is applied to the line value, increasing in steps, and then it is reduced. So by doing this, a capacitance and the power factor are recorded in each steps. So there is a plot, the power factor or tan delta versus the applied voltage which is drawn. So this is generally it is of the routine test, but sometimes may be conducted on percentage basis as well. So then next we have internal or partial discharge test. This test is done to find the deterioration or failure due to internal discharges. So this will lead to that there is a failure because of this the composite insulation or the bushing which is going to deteriorate will lead to that there is a failure. So this is done by using internal or partial discharge test, so which we discussed in the previous case. So there is the voltage versus discharge magnitude as well as the quadratic rate. will give an excellent record of the performance. So this is nothing but we are plotting the performance which is observed based on the voltage versus the discharge magnitude. So generally it is a routine test for the high voltage bushings. Then we have momentary withstand test at a power frequency. This is done based on the Indian standard specification 2009 applied to the bushings. So the test voltage is specified in the specifications. The bushing has to withstand the applied test voltage without the flashover or the puncture at least for a 30 second. So at present, so this type is replaced by an impulse voltage test. Next one we have 1 minute withstand test at power frequency. So it is the most common and routine test. So it is carried in dry and wet condition at least for 1 minute. So in wet test, the rain arrangement is mounted as in the service. This is what we discussed in the previous condition. There is an artificial air rain chamber. The water droplet is falling on the element at a degree of 45 degree. So we are considering that it is an artificial rain which is falling on the element. So a properly designed bushing should withstand without flashover at least for 1 minute. So this test really will not give any information for its satisfactory performance in service, while impulse and partial discharges will give us a more information than the dry and wet condition. Then we have visible discharge test at a power frequency. So this is intended to perform to determine whether the bushing is likely will give rise to an radio interference in the surface, which is prescribed by IS 2009. It is conducted to determine whether is there any radio interferences while doing in the service of the bushings. We should make sure that there is no discharges other than that from the arcing horns or the grading rings should be visible to the observer in the dark room. Means so generally this process means that visible testing is done in a dark room, and there is an voltage which is gradually increased to the bushings, and it should capable to give any visible discharges other than the arcing horns across the god rings. So means these are prone to there is a formation of the corner rings. So this generally the test arrangement is same as that of the withstand voltage, but this test is conducted in the dark room compared to that other one. Second test is impulse voltage test. So again here there are the two different types: full wave withstand test, chopper wave withstand test. The bushing is tested for either polarity voltages as per the specifications. There is a 5 consecutive full wave voltages applied. If 2 of them flashed over, then we have to do a 10 additional application. So if only one flashover occurs, then we have to do a 10 additional testings. The test object has to withstand, otherwise we have to conduct subsequent applications of the standard impulse voltage. Then only we will say that test is passed. So it means that we have to do a fire test. So while conducting the fire test, if one of the wave which is going to be in flashover, then we have to do a 10 additional application of the voltage which is done. So if there is no flashover, then we'll say that test is passed. So while applying a 5 consecutive full wave voltages, if nothing is goes, then we will say that the test is passed. Then we have to go for a second one, that is the chopper wave withstand test. The chopped wave is sometimes done for the high voltage boosting of 220 kV, 400 and above of the voltages. The switching surge flashover test is included for high voltage bushings. The tests are carried out similar as how we conducted for the full wave withstand test. Last one we have thermal test, that is temperature rise and the thermal stability test. The purpose of this test is to observe the temperature rise and to ensure that it doesn't go into the thermal runaway condition. The temperature rise test is done at an ambient temperature of 40 degrees Celsius at a power frequency. The study temperature rise above the ambient air temperature at any part of the bushing should not exceed of 45 degrees Celsius. The test is carried out for a long time and increase in the temperature should be less than 1 degree Celsius per hour. This is very important. Sometimes the bushing have to be operated along with the transformer. In that the temperature reached may be exceed of 80 degree Celsius. So the temperature is high enough to produce a large dielectric losses and the thermal instability. So it doesn't mean that we are not considering only of the 45 degree. So if there is a bushing with respect to the transformer, then we are considering it 80 degree Celsius as well. For high voltage bushing, so this is particularly important, and hence the thermal stability test is done for the bushing the rated for 132 kV and the above. The test is carried out with the bushing immersed in the oil at maximum service temperature with 86% of the normal system voltage. So this is approximately, we will consider it is a root 2 times of the working voltage of the bushing, and hence the dielectric losses are about double the normal voltage. There is an additional losses account for the conductor of the ohmic losses. So this is being considered as unnecessary to specify the thermal stability for oil impregnated paper bushings of low rating. But for the large high voltage bushings, the losses in the conductor may be high enough to outweigh the dielectric losses. So this is the type of the test for low voltage rating and the routine test for the high voltage ratings. So these are the type of the different type of test which you're going to conduct for the testing of the bushings.